Hello everyone and welcome to day 9 of the 2024 Advent of Code. We're going to be using Python for this one, and I'm just going to jump straight into it. There's a little bit of a lengthy explanation for the puzzle, but essentially this is our input, or just a long list of numbers here. And what this defines is a file of length 2 and then a space of length 3, file of length 3, space of length. So it's file space, file space, file space, over and over and over. And so if we were to see here, we've got a file of length 2, and then a space of length 3, a file of length 3, space 3, file of length 1, and continuously. And then each of the files have a sequential ID starting with 0. So every other one's a file with ID 0, 1, 2 continuously. And it goes up to 9 in this example, but it goes much higher. And then, so we get something like this. And then what we need to do is, starting from the right-hand side, move numbers over and put them in the next available, the next available leftmost space. So, we move this 9 into here, and then we take this 9 and we put it here, this 8, we put it there, and they've just given an example here. You're just always taking them over until it's one continuous block, and we do that. We do that until it's one continuous block, and then we work out a number from that, which is a checksum, which is you basically go along and you go, okay, 0 times this one, 1 times this one, 2 times this one, 3 times this one, 4 times that one, and you keep going, you sum them up, and then it spits out a number. So let's get going with it. There's a few different bits, so I'll try and be as quick as I possibly can. So I've got the data here. This is the example we were just looking at, and so if I get that into a variable, so let's say we call it disk data, and we're just gonna put each line, we're just gonna store it as one long line. There's only one line actually, so I could say is equal to this, strip just to get rid of any new line characters, and then we're gonna print the disk space, disk data, just to get a sanity check. Yep, that's what we expected. And then broadly, what we want to do is we want to convert this data to what it calls a block, which is this notation here, where you've got this notation here where you've got some amount of file data, some amount of space continuously, and then you take that block and you want to consolidate the block. So consolidated, if I could spell, consolidated block, and we'll just call a method consolidate, takes the block, and then there we need to calculate the checksum, which is that thing that I described before where we're going along and doing that sum, and that's going to be our answer. Sweet, so let's do these one at a time. Firstly, we're going to do the convert to block, and for this we're going to go through the disk data, and depending on if it's an even or an odd index, we know that it's file data, or we know that it's space, it's blank data. So what I'm going to do is do it as a array rather than a string. You could convert this into numbers and dots, but as soon as you hit more than 9 files, you're going to start to have some complicated issues. So this is how I've chosen to do it, and we're going to keep track of the file ID here. and we're going to say for index and the data in our disk data. We're going to say if the index is even, like this, then we know it's like actual file data. So this would be, I'm just going to write out the general kind of structure for you here. So this would be file data, and if it was odd, then we know it would be blank space. And the way that we're going to implement that is we're going to say for an index that we don't care about in the range this data. So remember, it picks out, say, this one, 2, and so we want to add two things to this block. What are the things that we want to add? It's the ID that we just got here. So we want to add, we want to add the file ID, which is going to be going up sequentially. So twice we're going to add 0, and then once it's done, we're going to increase the file ID for next time, because then we're going to add some space here, and then when we wrap back around to here, 3, we want to add 1, because this would have gone up by 1 3 times. And then over here, we want to do something similar, but instead of, let's get rid of these passes. Instead of worrying about file IDs, we just add blank like that. So I'm going to show you what that looks like here if I was to print the block. Oh yeah, and then of course we need to actually return the block once we've done that. And that's here. And so, we've got 2 here, a space of 3, and then file number 1 with 3, space of 3, file number 2 here. And if you have a look at this, it's the same as this. We've just done it as an array rather than one long string. And now we need to consolidate the block. And so I'm going to write this other function, consolidate. And the way that I'm going to do this is to continuously from the right hand side take one of these and put it into the left, the first space from the left, so swap these two around. And so an array is a good data structure for this because it's easy to pop off the end and easy to insert. And what I'm going to do is I'm going to do that for this 9 and for this 9 and for these 8s as well. And whenever there's a space that I pop off or a blank space, I'm just going to continue. And so I'm going to keep going, keep going, keep going. And my end condition when I'm going to stop is when there's going to be no more space. So I can say whilst these empty strings are in the block, we want to continue. And then we're going to do something here. And then afterwards, once we've finished all the manipulation on it, we're going to return the block. Okay. And what are the things that we want to do? So firstly, we want to pop off the rightmost element like this. And this element is either going to be a number or a blank space. Like we said before, if the element is a blank space, we want to just continue. If it's not, then we want to go ahead and find the leftmost empty cell, so here, and then we want to swap or replace that cell with the popped element. Okay, so I'm going to get empty cell block, or just say empty cell. I'm going to say find empty cell. And you could do this inline, but I quite like having separate functions just to keep things nice and neat. So find empty cell. And the way that I'm going to do this is I'm going to say for index and the cell in this block, we're going to loop until we get the cell being empty, and at that point we're going to return the index. And whilst this should never be the case, if we don't get that, then I'll return none, because we're inside this while loop that checks to see that there is a blank space. So this should always return an index. I believe this is actually the same as if I'd wrote that, but I think this is just a little, there's nothing implicit here or implied. It's very explicit, very obvious. And then I'm going to get the block, and in the empty cell, or this is going to be the empty cell index. That empty cell is now going to be the element, and it's going to happen continuously until there are no more spaces, and then we're going to get a consolidated block. So if I was to print this consolidated block, you can see here, so this 9 was moved to here, this 9 was moved to here, then one of the 8s, so this 8, these ones were there, and then the rest of the 8s, the 2, all of the 7s fit in this group of 3, and now we want to go ahead and make this checksum, which is relatively simple. It doesn't need to be on a consolidated block, it can be on any block. And the way that we're going to define this is to say checksum is equal to 0 to start with, and for each of these elements of the block, we're going to, in fact, I'm going to stick with the pattern I'm already done. Block, index, and element. I'm going to say the value of this particular element is the index times the element, and then I'm going to add that to this checksum, and then at the end I'm going to return the checksum. And hopefully both of these are integers, and hopefully I've put them in correctly. But after all's said and done, I should be able to print the answer here. Am I printing multiple things? Printing a few things. Oh, I didn't, the disk data. So I get 1928, and if we just check the example, 1928, so if I do it on the full data set, what I did was to say in here, I know it slows it down a little bit, but blank space left, and then I did block, I believe it's count, like this, and this should count down to 0 because we're doing it until there's none left. Here we go, yeah. And so there's quite a lot, so I'm just going to let that run, and then we'll get the answer. There we go, that's run now. That did take a little bit of time, maybe about 60 seconds or so, maybe even a little bit longer. But that our answer here ends in 548, and we'll just check it, that's the answer there. So I'm sure there are ways to make this faster, more efficient, but for now we're going to stick with that. And now we'll move on to part 2. This one's similar to the first part in where we still get this block, but now when we move over the files, we don't just do a single sort of part of the file at a time. We would attempt to move the whole file. And so this 9, we go all the way to here and try and find a space for it. So that would fit into this gap. Then we'll take this file here, file 8 of length 4, look back, see if there's any room for it, and there isn't. Okay. Same with, now with 7, length 3, we see that fits into this gap. And so we're going to go through each of the files one at a time, trying to find a gap for it. If there isn't a gap, we just leave it in place. And if it is, we put it back. And then there's a small change to the checksum in that if when we're going through the checksum, because it'll look like this now, we'll have these dots. If it is a dot, we just skip and move on to the next one. So, excuse me, the index will still go up, but it'd be effective as if these were 0, you know, so they wouldn't contribute anything. So let's go back to here and say consolidate whole files, and it won't be too dissimilar. Won't be too dissimilar to our last one, which is here. Say consolidate whole files block. And the way that we're going to think about this is I'm going to get the current file ID just by getting the last bit of the block. So that's there. And again, well, similarly, but not again, I'm going to go through every file. So in this case, I can't say while there's space in the block, empty space in the block, because we're going to end with some empty space, so we just run forever. What I'm going to do is count all the way from this last file until it becomes negative. I'm going to do some stuff, and then I'm going to return the block. Okay, and then just like before, I'm going to have a print statement for tracking later for when we run it, because it does take a little bit of time, this. And this time I'm going to say file being worked on, and then I'm just going to print this. There we go. That's just for later. And so what we can say is, if this thing that we just popped off, if this thing that we just got from the end is actually a blank space, so it's not a file. So if this were to be an empty space, well, we can just pop that and then continue. So let's continue, pop and continue. Well, get rid of this pass. And now what we want to get is the file size for that ID. So if we go back here, with this 9, we need to know that it's size 2, so we can then be looking for a gap of size 2. So I need some kind of function like get file size for ID, and I can pass in the block and the ID that I want. So this is going to be file size. And then with that file size, I need to know, it probably could be done at the same time, but I need to know where this file starts. So where's this first 9? Because then I can then, you know, take this bit and put it somewhere else. So I need to know the length of this, and I need to know where it starts. So I could say file index, and that would be get file, it's the starting index. So file starting index. Again, this block and this ID. And then I need to find a blank section over here that's that size. So here of size 2, of size 3, of size 4, and if it's size 4, sorry, if it's a size that's bigger than all the gaps, then I just want to return none. So I could say blank section starting index, and I could say find blank section of size, and for that I'd have to pass in the block and I'd have to pass in the file size. Okay, and then I could say if that section that we've just found, so if the blank section index is none, i.e. there isn't one, then just go on to the next file. So because we're counting down, yep, and then go to the next one. Continue. And then if not, replace empty cells with file, which I'll do that in a second. There's one more thing to think about here. So yeah, if in this case we're looking for 4 and there isn't a gap of 4, we leave it. But also when, say we're looking for a gap of 5, so say there were 5 6s, we don't want any gaps that's to the right of the file, because then we'd be moving it along and we're trying to move it to the left. And so one thing we could say if there is no blank section, or the blank section that we do find is further along than the file starting index, then don't do anything. Okay, and then for the replacing, we will just say the block from the starting index to the starting index plus the size, the file size. We want to make that sum array, which I'll show you here, of size file size. So we're just snipping out a chunk of this size starting at this index, and we're going to make it another chunk of the same size, and what's going to be in its place? Well, it's going to be the file ID. And then underneath that we want to do something similar but at the end. So at the file index, so the thing we just moved, we've essentially copied the file with this line. To then delete the old file, we want to take a file size chunk starting at the file index, file starting index. So this is at the end of this block, and there we just want to make it blank. And so then when it's going through, it'll remove these if needed. And then after we've done that, we want to say, okay, now we've done the nth file, go to the n-1 file, and go like that. Great, so this is the rough structure here. And now we just need to implement these three methods. So firstly, let's do this one. So this was to get the file size. Now, since we know that files have unique IDs, what we could do is just take all the elements of the block and throw away all the ones that are not that ID. So E for E in block, if E is equal to the current file ID. So that's saying take all of these, say we're looking for these 9s, and only keep ones that are equal to 9, because we know there's not going to be 9s anywhere else. And for us, we have an array, so there's no issue with multiple digit IDs. And then all we're going to do is return the length of that, and that'll tell us how many there are. And then for this second function here, this is getting the file ID, getting the file starting index for the block And there's actually a nice built-in function for this that we've already seen here. I think we have seen it, the index function. We might have seen it on a previous day. But this inbuilt function will return the first time this ID is found in the block, which is exactly what we want. We want the starting ID, the starting index of where that file is. So that's great. And then one more method here, which is slightly more involved. It's going to be similar to this one. So let's take that. And so this says, okay, at the first blank cell from the left, return there. But what we really should do is start another internal loop that tries to count up to whatever size we want. Say we want size 2. And when it hits that, it then returns this, this initial index. Say we wanted size 4, it would 3, that wouldn't work, and it'd go to the next one. 3, that wouldn't work, and it'd go like that. So what we can say is, I want a little bit more control over the index. So instead of doing a for loop, I'm going to do a while loop. So whilst the index is less than the length of the block, so we're going to check the whole thing, and we're going to make index 0. The cell is going to be block at that ID, and we want to keep track of the current gap size, which is 0. So what we're going to do is we're going to go along, and if the cell is empty, then we're going to do some stuff on it. We're going to be interested in that. If not, then just increase the index plus equals 1 and reset the gap size, because you may have, say, got a gap size of 3, but we're looking for 4. The fourth one isn't empty, so we go down here and then we reset the gap size. Okay, so what if the cell is empty? Well, we want to, first of all, we would say the gap is 1 larger than it was before, and we will then be moving on to the next one. We could do there we go. We could do it in either order, like that. And then we're going to say, okay, if now the gap has increased to the size that we want, which is this file size, then we should return the index. But at this point, the index is, say we wanted a gap of size 3, it's at the end here, so we want to move it back. So we would move it back the gap size amount. So move it back that much, which would get us the start index. And so that should be everything. If we were to run this on the example data, and we were to go down here and say convert to block, consolidate the whole files. Oh yeah, and then we need to do the checksum. But let's just check that our consolidated block looks as expected. So it looks like it only did 1 file and then stopped. So let's debug. Okay, so I've found the issue with the code. There's 3 small bugs here. The first one being here, I don't want to check the file ID because the file ID starts at 9 in the example and then goes down all the way to 0. I don't want to check that it's blank. What I want to check is the last part of the block is blank and then pop that. I think I just got that mixed up. Second was here. This was just a typo. So rather than decrementing the file ID, I was setting it equal to -1 in both cases. And then one more tiny bug in here, see if you can spot it. It's that after a cell has been checked to be empty, and we've increased the gap size and we've increased the index size, we've done this check, we don't want to then reset the gap size to 0, because then we'll never find a gap size unless the gap size was 1, you know. So we want to continue here. And then we would skip this bit and we go back to the top. And when we do those, we can see here that our consolidated block looks like this. 09217 at the start, 09217, and then, you know, the rest kind of spread out here. And the very last thing we need to do is, if we were to do this, we get an error, because like we were saying before, in this checksum now, there's the possibility that these elements are blank. And the instructions just say if the element is, sorry, not blank, is a dot. Sorry, in our case, they are blank, but in the example given, they're blocks. They're dots, say here. We want to then skip, so continue. And if I run that, I should get a number that says 2858, and I check that's 2858. And again, I'm going to run, I won't print this, I'm going to run the program on the full data, let it run through, and then I'll show you the answer. Okay, the program's run now, and we can see we get this large number ending in 311, and that is the answer here. And that's the solution for part 1 and 2 for day 9. Yeah, so the part 2 was sort of changing some of the implementation from part 1, but similar to some of the other puzzles, because of the way that we built it up, we're able to just modify it slightly, still using this same approach, changing the consolidate function and then slightly changing the checksum function. It does run a little slow. I'm sure there would be ways to optimize this. Maybe the way that I'm doing it, the kind of overall approach is slow, you know, the way that I'm moving from left to right, from right to left and doing one at a time. I did experiment with taking them in chunks. So say like here, especially for the first one, if I know there's a gap 3, I could get the last 3, reverse them, and then replace them here. And I wasn't seeing very much speed up. So, you know, maybe there are better ways out there to do it. And if you have a better way or can think of any improvements, please let me know in the comment. If you have liked, please remember to like the video and subscribe for more of these. I'm going to be doing a video on each of the day's puzzles, but they might not necessarily come out on the day that the puzzle comes out. Great, okay, and I'll see you for day 10.